from CSC 522. Today I'll be presenting about superconductor basic energy storage. So this is a presentation agenda starting with introduction, then moving to grid stability and current limitations of the present solutions. Then what is superconductivity? Let's move to SMEs and future advancements and conclusion. So this is the introduction. Out of all, growing need for energy is an immediate challenge based on it. As we transition onto the future powered by renewable resources, we need a way to store vast amount of energy, a way to capture sun power and release it when stars come out. So for that, the answer is superconductor. It's a technology promised with superconductor-based energy storage, where electricity flows with zero resistance and energy can be stored indefinitely. So for the current scenario where we have intermittency and grid instability, the reliance on fossil fuels has brought the climate crisis. So transition to cleaner and more sustainable energy sources like solar, wind, and hydropower is very much required. But sun doesn't always shine and wind doesn't always flow. So we need a solution which can. So we need a solution so that the energy can be stored when it is abundant and can be used when the demand is high. So we have renewable energy. These solar and wind are intermittent, and we have power fluctuations. That means the fluctuations of the power. Sometimes it could be low voltage and sometimes it could be high voltage, which causes the grid instability. And then we have demand variations. So the demand is quite low during early hours of the morning, and it would rises to high till the night. Then moving to limitations of current solutions. So batteries first, the basic energy storage we have is batteries. Batteries are great for small scale applications, but lose charges over time. Then we do have pumped hydro energy storages. These are good for greater storages, but they are geographically restricted and have significant environmental impacts. Then we do have compressed air energy storages. These stores a lot of energy, but the energy could be lost as a heat during compressing and decompression of the air. And if there are any airborne contaminants in the in the air, then it decreases the efficiency of the compressed air energy storage. So these are the limitations of the current solutions. So let's see what is superconductivity and a little bit about superconductors before going to SMEs or SBEs. The two key properties of superconductors are zero resistance and the electron motion of how they move inside a conductor. So these superconducting materials exhibit zero resistance so that there won't be any collision of particles in the movement that causing any heat loss. So these are highly efficient. So there is no loss of energy in the form of heat. And electron motion. In superconductors, as there is no resistance, there is no collision of particles. The electrons are moved in a proper symphony. That means a perfect motion of symphony. There are two types of superconductors, which are type 1 and type 2. The type 1 superconductors, these follow Meissner effect. So what is Meissner effect? Let's see. So Meissner effect is a phenomenon where superconductor or superconducting material completely expels magnetic field from the interior. That means they do not possess any magnetic field in the interior. And because of they do not possess any magnetic field, these cannot be used for energy storages. There are type 2 superconductors which allows a partial penetration of magnetic field. Since these allows a little bit of magnetic field, they can be stored energy in the magnetic field in the form of magnetic field. So these can be used in multiple applications like MRI machines, power grids, and SMEs. So let's see what is SMEs. So these are the key components in SMEs. One is key terminology actually. One is magnetic field, one is scalability, and another is rapid responses. SMEs uses a giant superconducting coils which are kept at ultra low temperatures. So, and these are the coils which are capable of storing vast amount of electricity, similar to a battery, but highly efficient and quick response, which possesses quick response. Scalability. SMEs is quite scalable. Systems can meet various energy needs. They can be used for low power outputs and for higher power outputs as well. And rapid responses. SMES just injects power into the grid quickly, very rapidly, and it's with also supports with grid stability also. So here are the key components of SMES. One is superconducting coil, which stores the magnetic field when the current flows through it, and another one is the cryogenic cooling systems. These to possess the characteristics of superconductivity, the coil that we are using should be maintained at ultra low temperatures. For that purpose, we use cryogenic cooling systems. They generally maintains the temperature as low as the critical temperature for that particular material we are using it for as a superconducting coil. They uses liquid helium or liquid nitrogen to maintain that low temperatures. Then power conditioning systems, which converts the DC power to AC power and also AC power to DC power. Generally, the energy flows as the AC before storing it into the coil, and it could be stored as a DC and it will be used for applications as AC. We will see about it in few further slides. Then moving to control systems. These monitors the voltage, current and the temperatures of the cryogenic cooling systems. So here are the steps that coil goes to when SMES is working. So first step it is cooling. The superconductor coil is extremely cool to low temperatures. This is critical for superconductivity, as the statement itself says. So superconductivity, the energy, the resistance could be maintained to zero when they are cooled to low temperatures. And then coil charging. When the energy flows through the electric current flows with zero resistance and it creates a magnetic field, and this energy is stored in the form of magnetic field. Then discharging phase. The stored energy will be released into the grid. So this is one simple diagram of SMES system. This is a very abstract diagram. The cryogenic cooling systems we can see that which maintains the which helps in maintaining lower temperatures for the coil, and the power flows to power conditioning or switching devices that helps in converting AC to DC and then DC to AC. Utility systems from which we could get power from. It could be either solar or wind or anything, and load is the application that we are using. So here is another view of SMES working. So the first step is charging grid power, which is converted from AC to DC, flowing into the superconducting coil. The grid power that which is in AC form can be coming from any of the applications. It could be either solar or wind or hydro. Then it is converted to DC using the switching power conditioning or switching devices, and the DC current that flows in the coil stores the energy in the form of magnetic field, and then discharging. When there is a requirement, the energy is released by reducing the current, which is an inverter converting it back into the AC for the grid. So these are the advantages of SMES, and it provides a nearly 100% efficiency. SMES systems uses the unique properties of superconductors, which provides the unparalleled energy efficiency since there is no electrical resistance, and it exhibits a lightning fast response. That means quick response. SMES can discharge energy in mere milliseconds, providing the grid with rapid responsiveness needed to maintain the stability. And unlimited charge cycles. Unlike batteries, these batteries degrade upon charging and discharging, but SMES doesn't degrade upon charging and discharging. These doesn't possess any degradation quality, allowing for unlimited charge and discharge cycles with no loss in the performance. And it provides a high power density. The powerful SMES, like we seen, that the energy can be released in very quick responses. For high and large scale applications, we can use SMES, and it is completely environmentally friendly since it doesn't possess any environmental charges, unlike air compressed energy systems or pumped hydro. It doesn't possess any of the environmental impacts, and it doesn't use any toxic chemicals like batteries. So it is environmentally friendly in the chemical way also. So here are some real world applications of SMES. And for power grid applications, it maintains the grid stability. It absorbs when voltages are high, and it absorbs when energies are high and releases when energies are low. and it also performs the voltage support also. We have few applications which get damaged or failed when the voltage is quite low and voltage is quite high. These voltage fluctuations can also be dealt with SMUs. And we have industrial applications as well. These first thing is one of the industrial applications is semiconductor manufacturing. Power and SMEs ensures stable power supply for semiconductor manufacturing things and data centers. These data centers should be powered 24/7. If the power is down, then there is a chance that data could be lost. So SMEs provides a 24/7 power supply for data centers, prevents any downtime from power fluctuations. And renewable energy integrations. SMEs is very much used for solar and wind smoothing. Since solar energy cannot always be available and wind energy cannot always be available, SMEs is what is the best option for energy integration. And challenges and limitations that could be possessed for SMEs. The cryogenic cooling systems are quite expensive to maintain the low temperatures in like to critical temperature. The cooling system should be highly sophisticated. For the perspective, the cooling systems are quite costly and material roadblocks. Advancing room temperature superconductors is major technical hurdle. Like the temperature, the superconductors that we are using now are low temperature superconductors only, and they are advancing towards the room temperature superconductors or high temperature superconductors. They are actually possible, but they are highly expensive. And cooling infrastructure. Specialized cryogenic systems add complexity to SMEs deployment. So advancement in SMEs. So like I said, the room temperature superconductors are also like in the research process. So if they are available for SM, if they are available, then the cost of cryogenic cooling systems can be reduced. And we also have high energy density SMEs. They generally uses PSSCO or MgB2 magnesium B2 to boost performances. The PSSCO is one of the high temperature superconductors, which made SMEs more viable option. So BSSCO, the name specifies bismuth, strontium, calcium, copper oxide superconductor. And AI powered integration also available in the SMEs. This is one of the advancement. Every other object is involved with AI, so that IoT applications are being improved. Then moving to the conclusion, though the superconductor have challenges and limitations, the future of SMEs is quite good. As research progress and costs continue to decline, we can expect to see a wide adoption of the technology of this technology as they provide the rapid response, efficiency, high efficiency. Like they do possess nearly 100% efficiency, and they are they can be integrated with renewable resources. Thank you.